pause this video so you can write down these notes. But this slide is talking about limits of functions, and it's very similar to the one with sequences, okay? The only difference is that now you actually have a function here, and you're evaluating basically as the limit approaches a particular number on your function, what y value are you going to have? Okay, so the value of x becomes really close to c from either side. C represents the value on your x-axis. The function becomes really close to a fixed value L. If the function does not become close to the fixed value, that means coming from the left and the right, the limit does not exist. Okay, so let's take a look at these examples right here. And after that, we'll be done. Okay?
Take Powell, please come back to the office. Take Powell, please come back to the office, or I'm taking your present home.
It says find the limit or state that the limit does not exist. We'll look at the first one, x squared. For this, you'll need your calculator, okay? So pull it out. All right? And under y equals 1, you're going to type in that function x squared. So go ahead and do that. And now, look at the graph. All I did was I pressed zoom and 6 to get it back to the standard window. And there's the graph, x squared. It's quadratic, it's a parabola. And so you're basically asking yourself, okay, as I get closer to 2 from the left and the right along my x-axis, what y value am I approaching? It might be kind of hard to see with the graph, so you might actually want to look at the table. We're going to need to change some settings first. Just real quick, yes, I want to make sure we're approaching 2. So you're going to press the second button, and you're going to press the table set button. I'm going to start at 2, because I want to see what's happening as the curve approaches 2, as x approaches 2. So I want to start at 2. And you see where it has this little triangle TBL? That basically means how much do I want the x values to increase? And I'm going to leave that as 0.01. So then I'm going to press the second button and then the graph button, and what it's going to do is it's going to show me the table. And right now I'm starting at 2. And as I can see, is as x approaches 2 from the right hand side, okay, think about from the right, you're coming from like 4, 3, into 2. As I'm approaching x from the left, from the right hand side, I'm actually getting closer and closer and closer to 4. From the left hand side, I'm just going to scroll up to look at some of these values. As I'm approaching 2 from the left hand side, I'm getting closer and closer and closer to 4. So the answer to this one would be, as the limit, as x approaches 2 of x squared, it equals 4. Okay? Do the same thing for B. Pause this video and do the same thing for B. Hopefully you typed it in like this, so when you go and look at your graph, this is what you get. Looks like a line, huh? So you want to take a look as it approaches 1. So make sure you change your table settings. And then when you go and look at your table, you see an error message. That's interesting. I wonder why there's an error message, but we'll talk about that later. And as you see, as x gets closer and closer and closer to 1, from the left-hand side, y is getting closer and closer and closer to 2. Coming from the right, as it's approaching 1, it's getting closer and closer and closer to 2. So the answer here, as the limit, as x approaches 1 of this function, is going to equal 2. Now for C, it's a little different. This is known as a piecewise function, because basically, it's a function that's been broken up into pieces. Remember, f of x equals y. So basically we have two equations, y equals 1 and y equals negative 1. But we're only concerned about the y equals 1 for x is greater than or equal to 0. Okay, if you recall, y equals 1 is a horizontal line. It is defined at 0 and everything greater than that. To graph y equals negative 1, it's all the values that are less than, all the x values that are less than 0, and it's not defined, so there's going to be an open circle there. And if you look, as I approach 0 from the right-hand side, I'm getting closer and closer and closer to what y value? 1. As I'm approaching 0 from the left-hand side, I'm approaching what y value? Negative 1. Now, I should be approaching the same number no matter if I'm coming from the left or the right, like how I did for A and B. So when that happens, when you don't approach the same number, then the limit does not exist. The limit does not exist. That's how you figure these things out algebraically. Graphically. To do it algebraically is actually pretty simple. All you do is you take the function and you plug in the x value. 2 squared equals 4. Same thing we got when we did algebraically. Over here, when we plug in 1, we'll actually get 0 over 0. When this happens, we gotta do one extra step. What's that step? Look at the top and the bottom. I can factor out the top, can't I? Yes, I can. That's difference of perfect squares. So when I do that, I'll see, hey, my x minus 1s cancel out, leaving me with just x plus 1. And when I plug in 1, I get 2. For your piecewise functions, you would technically do a similar thing, but you would plug into both pieces of your function, okay? And then if they equal each other, then you'll know what the limit is. But look here, I have y equals 1 and y equals negative 1. There's no place for me to plug in any x value because there is no x. So even right here, that should let you know that the limit does not exist. And just for the sake of it, okay, I'm going to make up one just real quick. Say you had this piecewise function of x plus 3 and then negative x minus 2. And let's say as x is greater than or equal to 2, x is less than 2. And I wanted to figure this out algebraically. Well, all you have to do is plug in 2 into the first equation, plug in 2 into the second equation. You see how this one equals 5 and this one equals negative 4? They would have to equal the same thing in order for the limit to exist. If they don't, then the limit does not exist. Very quickly, if I were to look at the graphs, you would see the exact same thing. I want to graph x plus 3 when x is greater than or equal to 2. So that means I'm going to go a little higher. That means I'm going to have to start at 3, 1, 2, 3, go up 1 over 1, up 1 over 1. Here is what I'm really concerned about for all the values that are x and greater. Up 1 over 1, up 1 over 1, up 1 over 1.
Teachers, Ms. Johnson will be here for the faculty meeting at 3:35. Thank you.
Okay? For this, I'm going to start at negative 2, and then I'm going to go down 1 over 1, down 1 over 1. So in this case, I'm only concerned about the values that are less than 2. So I started at negative 2, I went down 1 over 1, down 1 over 1, which means I'll go up 1 over 1, up 1 over 1, so on and so forth. This, roughly, is the graph of this piecewise function. And if you notice, as you approach x from the right and x from the left, I'm approaching 5 and negative 4. These are not the same. That's why the limit does not exist. If you have any questions, let me know.